In this video, we will learn about seasonal change that emerged from the analysis of NDVI monthly data. We will see how seasons in Ecuador have shifted over time and some of the implications of these shifts.
In the last video, we saw how NDVI values across Ecuador have been greening since the 1980s. But these greening patterns don't show up identically in every ecosystem. Each of the 4 regions we identified had different seasonal vegetation pattern changes. No 2 regions were alike in how they responded to the climate changing over time. But if greening trends are strongest at different or changing times of year, regions can undergo seasonal shifts. Things like the growing period getting longer, or peak vegetation growth happening at a different time of year entirely. This can have big implications for everything from wildlife conservation to agriculture. So, let's take a look at the potential seasonal shifts that we observed in regions across Ecuador. To evaluate seasonal shifts in NDVI, we used NDVI anomaly data for each of the 12 triads of the years. We used linear regression to see how pronounced long-term greening was for each triad, and also to identify whether or not changes were associated with months of higher or lower rainfall. To put it very simply, if a triad experienced no trend over the years, a best line fit in a linear regression would be flat, or with a slope of 0. Conversely, the steepest the best fit line, and the more positive the slope, the more greening it indicates. Let's check now what our regression analysis revealed in terms of different greening patterns across regions and the seasonal shifts that might be associated with them. Now, this graph might look daunting, but it's just a visual representation of the regressions that we've been talking about. Each little sector of the circle represents a triad, and each region has a data point associated with each triad. Now, the further that data point is from the center of the circle, the more greening that region has experienced during that triad over time. Filled-in circles are statistically significant, meaning we're quite confident those greening patterns didn't just happen by chance. I'll also throw in some graphs that show NDVI over the course of a year in each region. The purple line shows an earlier time period of the study from the early 80s to the early 90s, and the green line shows a later time period of the study from around the late 90s to 2010. Now, if the green line is much higher than the purple, it means there was lots of greening over time. Thanks for sticking with us. This is a complex video, but now we can finally discuss results by region, and we can show you it visually. First, Amazonia. Greening trends are strongest here out of all the regions of Ecuador, and there's significant greening changes happening for 6 of the 12 triads, basically September through February, which correspond to the dry season. Comparing the 2 time periods, basically the 90s and the 2010s, we see a seasonal shift of 3 to 4 whole months. The NDVI yearly peak is now around November instead of August. The growing season, where NDVI is highest, has grown stronger and is happening later in the calendar year. In the East Andes, the growing season has also lengthened, but due to significant greening happening both around September and around February. Why the 2 different trends of greening? Well, possibly a similar relationship with rainfall than that of the Amazon, but we don't know for sure. Still, the maximum NDVI values in the region haven't increased much. They've mostly just shifted when in the calendar year they happen. By contrast, the coast region showed no clear seasonal shift in the study. The growing season has become significantly greener, a lot more intense, but it still happens at the same time of year. And this is actually during the period of the most rainfall, which is in stark contrast to Amazonia. Finally, the West Andes. Here, the study's results show no seasonal shift and no statistically significant greening. Sure, there's a slightly higher NDVI maximum in the 1997 to 2010 period than there was in the 1982 to 1992 period, but not by much. Why did the West Andes and the East Andes seasons shift in different ways over time? We're not entirely sure. The drivers of vegetation change in the Andes in particular are poorly understood, which is both exciting because it means there are questions that need answering, but frustrating in the here and now. Each of the 4 Ecuadorian regions studied had different, unique greening patterns and seasonal shifts over time. Amazonia and the East Andes saw a significant lengthening of the growing season and even a distinct seasonal shift. Meanwhile, the coast and the West Andes had no significant seasonal shift at all, and while the coastal region experienced some significant greening over time, the West Andes had no significant greening, though we did see NDVI increase a little bit over time.
In this video, we analyze seasonal trends in NDVI data that emerge from our analysis. Specifically, we look at different greening patterns across different regions in Ecuador, and some of the implications of these differences. For your own reflection, think about what will happen if seasons start shifting in the area where you live. Think about agriculture, forest, or other types of vegetation.